Good afternoon, everyone, and welcome to our very first Air and Space live chat. Today, we are so happy to be joined by the John and Adrienne Mars, Director of the National Air and Space Museum, Dr. Ellen Stofan. Ellen, thanks so much for being here.
Oh, I'm excited to be here with you today.
We are going to be taking as many questions as we can live. So if you put them in the comment section of the Facebook page, or you can tweet us, we will get to as many of them as we can. Now, I want to tell you that Ellen is my boss. And in fact, she's the boss of everybody at the museum. So we're going to see if you guys can stump her. All right, are we ready to go? Okay, Ellen, I'm just going to start. Before you became the director of the National Air and Space Museum, you were the chief scientist at NASA. Can you tell us what that job entailed?
You know, it was really an amazing job. I was basically the science advisor to the administrator of NASA, who at the time was Charlie Bolden, who's my hero and just an amazing individual. So what I did as chief scientist at NASA, I really looked across the agency at all the programs that were going on, whether it was in heliophysics or earth science or astronomy, and really said, do we have kind of a coherent linked science program? But I also spent a lot of time on human space flight and thinking about the science we do every day up on the International Space Station, as well as working on plans of how are we going to get humans to Mars. So I got to do lots of different things. I got to do a lot of work with the administration. We were doing things like looking at Arctic policy on the oceans. So really pretty broad ranging, really fun job.
What is it about studying science that really inspires you?
You know, I guess I was always one of those kids who wanted to know why. You know, why is there a mountain there? Where did the mountains come from? You know, why does the landscape around me look the way it does? And when I learned that figuring that out was actually called geology, you know, to me, it was like always trying to solve a puzzle. So when I'm studying the surface of Venus or looking at lakes on Saturn's moon Titan, I'm always thinking about how am I going to figure this out? What happened here in the past? How did it change over time? And even more importantly, how can we use that to understand our own planet better?
Well, we're getting questions in already, and Max is 12. And he's interested in restoring old aircraft.
Cool.
And he wants to know, how can I get involved in restoring old airplanes now? Do you know if there are any places where I could volunteer to help?
You know, a lot of museums and places don't take volunteers until they're more high school age or college age. But if I were you, I would look into an organization called EAA. It's the Experimental Aircraft Association. They have a program called Young Eagles that have chapters all around the country in most every state. Some of them are out of local airports, and they do a lot with kids in terms of helping them. I know in some cases they are building airplanes, they're talking about airplanes, they're really learning a lot of the skills on how you make airplanes. So if I were you, I would start with EAA. I would also really make yourself look at the programs online. For example, you might not know it, but Embry-Riddle University, for example, has programs aimed at middle school kids on how to be a pilot. So if you're interested in all aspects of aviation, there is actually a lot out there, some of it online if it's not in your backyard.
And Ryan would like to know, what upcoming NASA mission are you most excited for?
All right, well, I'm really biased, and I actually have my, I don't know if you can see it here, I have my Dragonfly shirt on today. So I'm a co-investigator on a NASA mission called Dragonfly. And it's a really cool mission that's going to send basically a drone, a quadcopter to Saturn's moon Titan. It's going to launch around 2026, get there in 2033. And Titan is my favorite moon in the solar system because it's actually the only moon that has a substantial atmosphere. Its atmosphere is mostly nitrogen like ours. It's super, super cold at Titan because it's so far out in the solar system. But it actually rains there. And you could say, well, how can it rain if you just said it was super cold? But it's actually raining methane and ethane, basically like liquid gasoline. And it forms, the liquid methane and ethane form lakes and rivers. It evaporates back up into the atmosphere and comes down again as rain. So Titan is this really cool little alien moon that can help us understand things like Earth's water cycle. Who knew? Way out at Saturn. So the Dragonfly mission is going to land near the equator on Titan. It's going to study the large sand dune regions. Those are made up of weird organic particles that we'd like to understand. How close has the organic chemistry on Titan gone towards the origins of life? We're not sure that there's anything alive on Titan. It's very cold there. But on the other hand, we really don't understand a lot about the surface chemistry. And so the Dragonfly mission will really look at that chemistry in a new way.
And Charlie would like to know, following up on that, how does he become an astronaut? Or it could be she, actually. Charlie could be a boy or a girl's name.
You know, NASA's having a call right now for astronauts, but you're probably a little young for that. So the one thing I love, I've met a lot of astronauts, and the one thing that always surprises me is how different their backgrounds are. I've met astronauts who are medical doctors, engineers, all kinds of engineers, mechanical engineers, aeronautical engineers, electrical engineers. There have been astronauts who've been geologists, yay, astrophysicists, oceanographers. If you name a profession, chances are there's been an astronaut in any of the kind of sciences. There's been one. I think what, to me, if you're really serious about wanting to be an astronaut, find something in the sort of science, technology, engineering, math, computing, design field. Become really passionate about it, really go all out, but stay well-rounded. Do things like take flying lessons. That's what's going to prepare you to be an astronaut, not any single career path.
Katie says, hi, Dr. Stofan. I went to be a museum educator in space and aviation and as their dream job 30 to 40 years from now. Would the, or maybe even the director of NASA, I'm currently deciding if I should get a specialized PhD in planetary science or history, or if I should get a degree in museum studies education. Which would you recommend?
You know, Katie, I would recommend any of those because, first of all, it's so awesome that you want to become a museum educator. You know, our museums, like Air and Space, to me, are so important for doing things like this. We're getting kids excited about the future. You know, what are we capable of? Where are we going to go next in space? You know, who's going to invent a new airplane that might be more fuel efficient and help with climate change? Museums are places to inspire the public to think about how we create a better future. And so I'm really excited that you want to be a museum educator or a museum director. A lot of my fellow museum directors, some of them have a background like me where they maybe excelled in a specific field, like I did in planetary geology and then came to run the Air and Space Museum. Other people did have careers always at museums. And so they had maybe museum studies, or as you say, a history degree. For example, the secretary of the Smithsonian, Lonnie Bunch, who used to be the director of the African American History and Culture Museum, he's a historian. So his degrees are all in history. So lots of different backgrounds, but just like with the astronaut thing, do what makes you excited. Do what makes you really interested. You know, when my kids were trying to figure out what to major in college, I always told them, when you look at all the courses, if you want to take every single course because you're like, I can't decide, I love all of those I want to take, that's what you should major in.
Shauna would like to know, what is up with the induced magnetic field from Venus's atmosphere?
So, you know, magnetic fields are really complicated things that we don't completely understand. And so one of the things that's really interesting about, if you look at Earth, Mars, and Venus, the Earth has a very strong magnetic field. It's really important because that's what helps protect us from incoming solar radiation. So we love our magnetic field, but there's lots of things that we don't understand about it. Magnetic fields we think are caused by basically convection in the core of a planet. And that's what produces ours. But if you look at Mars, what we've been able to figure out about Mars is that it had a magnetic field early in its history, but now it doesn't. And we think that's because Mars is very small. And so over time, its core probably has cooled and it doesn't have a magnetic field. Now, if we talk about Venus, Venus doesn't have a magnetic field like Earth's. And that's kind of weird because Venus and Earth are about the same size. They should be made of about the same material. So why doesn't Venus have a magnetic field? Does it have something to do with the fact that Venus rotates very slowly backwards? Could it be that Venus's core composition is just slightly different than the Earth's? We have a lot of unanswered questions about the lack of a magnetic field at Venus. We don't even know if it used to have one and now doesn't. So lots of questions. And then there's this question of the fact that the circulation of the atmosphere on Venus seems to be inducing a very slight magnetic field, not the big kind that helps protect us from solar radiation. Venus is very much being affected by that. So really complicated stuff. Great question.
Nora is 6 and wants to be a space scientist. What are some good books I can read? And also, what is your favorite planet and why?
Okay, I'm gonna answer the second one first. Oh, my favorite planet is Earth. Because no matter where we've gone in the solar system, and so far looking out at planets around other stars, the only planet we found that humans can live on in any kind of easy way is Earth. And so to me, when I go out and study other planets, it's always to figure out how can we understand the planet we live on better. Titan is my second favorite. You probably got that from my answer about the Dragonfly question. Books you can read, that's a great question. And so one of the things that I tried to do when I was your age is I tried to find biographies of women who were scientists so that I would learn about different careers in science to figure out which was the one I wanted to. And at that time, hardly any of those stories were being told. So it was really hard to find biographies about women scientists. But now there's an awful lot of them out there. So you can read biographies of people like Katherine Johnson, the mathematician who helped us figure out how to get humans into space. There's biographies about famous women astronomers. There's biographies about famous women planetary scientists. I know there's a biography about a friend of mine named Rosalie Lopez, who's studies volcanoes. So I would really go to the library and try to find every book you can about women scientists, and hopefully some of those will inspire you.
We are getting tons of questions. We're going to get to as many as we can, but keep them coming. Kaylin is 8 and wanted to know, how does the moon control the tides as it orbits the Earth?
Well, Kaylin, there's something called gravity. So every mass is always pulling on every other mass. It goes back to the basic laws of physics and a guy named Newton who helped figure this out. So everybody, the larger mass that a body is, the more gravity or the more pull it has on another body. So you might think, well, how can something as small as the moon actually affect the Earth? Well, the fact that the moon does have a mass, it's enough that actually the ocean, as the moon moves around, the oceans are actually being slightly tugged on by the moon. And that's enough to cause the water to bulge out and then recede, depending on the relative position of the Earth and the moon. So it's this force of gravity that is very cool, very fun to understand. And that is why even something like the moon can actually affect the Earth.
And our next one is from Toby. And Toby's 7 and would like to know, what do astronauts do to keep themselves entertained in space?
I've asked my astronaut friends this a lot, and they do lots of different things. They often have movie night, believe it or not, up on the International Space Station. And sometimes all the crews, the Russian crew, the crews who have come from Europe, and the American crews, they'll find movies they can all agree on. We can't do that in my family. I don't know how they do it up there. But they actually have a fairly well-stocked movie library up there. And they like to watch movies together. I have observed they seem to spend a lot of time playing with their food. Because just think how much fun it is to play with your food in zero gravity. You can float M&Ms in front of you and then chase them. I've seen all kinds of videos of astronauts doing crazy things like throwing a football and then floating down and grabbing it and catching it before it gets to the other end. They find lots of ways to play in zero gravity, to have fun. They read books. They call home to their families. In a way, not so different from what we do here on Earth to keep ourselves entertained.
I need to apologize if you hear some odd noises. My cat, for some reason, is walking around talking. So if you hear crying, it's the cat. He's been asleep all day, but now he's awake. Dr. Stofan, hope you're well. My son wants to ask, do you think that the SLS, Space Launch System, will be a cost-effective way to get us back to the moon?
You know, the really important thing about the Space Launch System is that it has heavy lift capability. So the rockets that we've been using and the rockets that are available right now don't have enough oomph, don't have enough thrust to actually get humans, which is a lot of mass. You have the spacecraft and you have all the people and their stuff. And so you need a really big push to get us to escape from Earth's gravity and be able to get to the moon, let alone to set us on a path to Mars. For that, you need a really big rocket. We haven't had a really big rocket since the Saturn V, which was the rocket that NASA developed to send humans to the moon back in the 1960s. So we needed a new big rocket. And so NASA started working with private companies to build the Space Launch System. And the capability of that rocket is absolutely what we have to have in order to get humans to the moon. And from a planetary science perspective, it's also really exciting to me because just think of it as like throwing a ball. So, you know, the bigger and stronger your arm is, the further you can throw the ball. Well, I study, you know, again, Titan out in the outer solar system. Right now, it takes, like for our Dragonfly mission, it takes 7-8 years for a spacecraft to get out to the outer solar system. If we had a big, powerful rocket like the Space Launch System, we could cut those travel times out to the outer solar system in half. And that's really important when you're trying to answer a scientific question and you're like, wow, I just learned all this information from the Cassini mission, and now I want to ask this follow-up question with a new instrument. And then you're like, oh, I think I'll wait 8 years till my spacecraft gets there. It's really hard. So a big rocket like the SLS is something we really have to have.
Oh, and actually, I got a question. Cameron, who's 12, wants to know what the name of my cat is.
Awesome.
The cat's name is Jackson. And he just likes to walk around and talk sometimes. We've got some people who are watching from the Mojave Desert, Blair, Minnesota, Ohio, the UK, only Texas, Savannah, Georgia, the Catskill Mountains in New York, and Columbia, Maryland. So thank you all for watching. Keep those questions coming. Nathan, who is 11, wants to know how much mass is in our planet.
Oh my goodness. I don't have the answer to that off the top of my head. I wish I did. That's a great question.
Nathan, I think you stumped her.
You can Google that.
This is an interesting question because
if I could just interject,
sure.
You know, sometimes I do have numbers memorized, but not also. But this is one thing I actually want to say to all the kids out there. I struggled in math. Math was never my strong suit, but you know, I knew I wanted to be a planetary geologist. And so even though I struggled in math and sometimes my grades were really not very good, but I stayed focused on the fact that I just had to get through it. And I have so many people who say to me, well, I wanted to be a scientist, but I struggled in math. And I'm like, oh, I struggled in math too, but you just have to stick with it. So all of you out there that are struggling in math, and so you think that maybe being a scientist or an astronaut is not for you, don't give up.
That is a very good tip. Every astronaut we have ever interviewed, every scientist we've ever interviewed has always struggled in some topic.
Yeah.
And some of them, they ended up being specialized in, and they just had to work extra hard at it. So that's very good advice. Jace, who is 9, would like to know, how cold is it in space? And I think that depends on where you are in relation to the sun, maybe.
That's a really hard thing to get your head around. Obviously, in space, it's cold unless the sun is shining on you, and then it gets really hot. And so just imagine the poor astronauts, they'll go out to fix something on the International Space Station, and they go out there for like 4, 6, 7 hours. I mean, they're out there a really long time. And the space station, they see like something like 9 sunrises and sunsets a day. So when they're out there working, inevitably they'll be in full sun, they'll be in partial sun, they'll be in darkness. When they're in darkness, they've told me they get so cold. I mean, their spacesuits are heated, but even so, their fingers especially will get really cold. So cold, cold, cold. You're trying to get your work done. You're trying to keep your fingers moving. And then you come around, the sun comes back out, and you're sweating because you're super hot. So it's one of those things. It depends on if the sun is shining on you or not.
We are still getting a lot of questions, and so keep them coming. Elise is 7 years old and maybe a little upset about Pluto, but wants to know, why is Pluto a dwarf planet now?
The way I look at it is, by demoting Pluto, we've made Pluto everybody's favorite planet. So I feel like this all in the long run did Pluto a favor. The problem is, it turns out, when we originally found the planets, we didn't have as good of telescopes, and we really hadn't searched as much as we were able to over the last several decades with much more advanced telescopes and a lot more astronomers out there looking. So in that time, we have grown to understand that Pluto is just one of the bodies in something called the Kuiper belt, which is a belt of material that's it's where Pluto sits. And there are lots of Kuiper belt objects that are probably on the size of Pluto. We also have some bodies in the asteroid belt between Mars and Jupiter, like Ceres, like Vesta, that are actually quite large and circular and about the size of Pluto. So, the way I look at it for kids is, would you rather memorize the name of 8 planets, or would you rather memorize the name of like 16 or 17 planets? So let's all be sad about Pluto, but let's all be kind of happy that we don't have to memorize, that we have these 2 categories of major planets and minor planets.
And we just wrapped up a STEM in 30 program all about exoplanets. So if you want to learn more about more planets that we couldn't see not very long ago, you can check that out. We've got more shout outs. People in Sarasota Springs, New York, the Rio Grande Valley of Texas, Omaha, Nebraska, Tennessee, Charlottesville, Virginia, and Chesterfield, Missouri. So we've got people watching all over. Someone would like to know, and maybe we should start, they would like to know, how do you become a mission control person? And maybe you should describe what mission control is.
Sure. The folks in mission control, we have at NASA, there's a lot of different kinds of mission control centers. So we have a mission control is where you're actually doing all the groundwork. You're sending commands up to a spacecraft. In the case of human spaceflight, you're interacting with the astronauts and monitoring the health of the International Space Station, monitoring the health of the astronauts, helping them plan their activities, helping them troubleshoot problems. So that's on the human spaceflight side. In a way, it's the same on the if it's a deep space spacecraft, like say the Juno mission out at Jupiter, or maybe one of our Earth orbiting satellites that's looking at Earth's climate or Earth's land surfaces. There are people who are monitoring, is the spacecraft healthy? Do we need to send new commands to tell it to do something slightly different? So you have 2 types of mission controls, more human spaceflight and then uncrewed spacecraft. Most of the people in those mission control rooms have some kind of engineering, computing kind of background, but that does vary. I would say most of them were engineers. A lot of them, in the case of human spaceflight, probably came out of aeronautical engineering. They went to work in the human spaceflight program and then found a different career path. But I think that would be great. If we don't have a STEM in 30 on a mission controller, that might be something really fun to do.
That is a very good idea. We do have a My Path with Gene Kranz, who talks about his time at Mission Control.
Yeah, Gene Kranz is kind of, he's the one that was during the Apollo 13 anomaly. He was in charge of mission control down at Houston, and he was the one that really ensured that we got Apollo 13 home, along with that whole crew down in Houston who had to work on that. And I will say, I worked on the ground for 2 shuttle missions. I was working at the Jet Propulsion Laboratory. We had a radar instrument that flew twice on the shuttle in 1994. And so I got to go down to mission control during in Houston during the mission, and I got to wear a headset and say Roger and Wilco and talk to the astronauts up in space. It was really fun. But boy, I tell you, I grew to be so amazed and awed by all the people in mission control, because their dedication to the program, their dedication to keeping the astronauts safe was really impressive to see.
And Gene was really great to talk to. He talked a lot about Apollo 1 and how that changed the way he thought about mission control. So you should check out the My Path series as well. Adele is 8 and would like to know, what do you eat and where in space?
It's funny, if you look at a lot of the clips of the astronauts up on the International Space Station, a lot of the times they're kind of wearing sweatpants or shorts and t-shirts. So it's usually pretty warm up there. So you don't tend to see them like sort of all bundled up. And frankly, they just wear whatever's comfortable. So that they can kind of float around. They tend to sometimes have little patches of Velcro so they can stick themselves somewhere if they need to. And that it was wear and
Eat.
They eat a lot of variety of food. And one of the things that working with the astronauts up on the International Space Station, they've realized how important what we eat is to our mental attitude. Like, just think, if you ate like a boring protein shake for every meal that tasted like nothing, you'd get really crabby. And so they really think about that when we have nutritionists who work at NASA, and they really think about, how do we give the astronauts really healthy meals, but that also taste good. And your taste buds, you do lose a little taste that kind of gets dulled in space. So how do we give them tasty food that's interesting? And the astronauts tend to pick what they like to eat, and they have sort of their own meals that get sent up for them.
Okay. Evan is 9 and wants to know how many planets have been discovered. Thanks. Now, I have someone who is giving me the cheat number, but if you want to talk about planets and exoplanets, then I can give you the number as of yesterday.
Yeah, I was going to say, that's a really great question. It's funny, I wrote a book a couple years ago with the astronaut Tom Jones, and this was actually back in like 2008, and Tom was writing the chapter on exoplanets in our book, and he kept having to revise it, because even back in 2008, I think the number of confirmed planets is somewhere at about 2,600.
Well, as of yesterday, it's 4,056.
Wow. So 4,056. So that number has been, I forgot, because now we have all the planets that have been being discovered by the Transiting Exoplanet Survey satellite. So that to me is one of the most exciting things that's happened. We were joking about Pluto. When I was in school, we had 9 planets, then we went down to 8 because of Pluto. That's a joke. But now people who are going to do what I do in the future, be planetary scientists, you have thousands of planets to study. And that's so important, because when we understand our solar system, part of how we understand the Earth is by putting it in the context of the other planets. And so then all of a sudden you think, how can we really understand solar systems if we only have one? And so from now, these thousands of solar systems that we're beginning to look at, we're learning, wow, there's a lot about our own solar system that we now understand better, can put in a different context, understand in a different light. So the discovery of these exoplanets, these planets around other stars, actually has huge information for helping us understand our own planet.
Zach is 8 and is from Northwest Iowa and would like to know how long it would take me to get to Pluto.
It took the New Horizons spacecraft about 10 years to get to Pluto. And that's kind of a short trip to Pluto. Pluto actually at times, because of the Earth's orbit and its orbit, it gets even further than 9.5 or so years away. So it's a really, really long trip. And the problem is you have to accelerate the spacecraft so much to get to Pluto that it's really hard to slow it down. And so the New Horizons spacecraft did not slow down. It zinged right by Pluto. So I'm a little worried, Zach, if you want to go to Pluto, you're going to need a spacecraft that somehow has really good brakes on it.
Calvin, who is 9 from Rhode Island, would like to know, what is your favorite exhibit at the National Air and Space Museum? Now, I know this is probably a hard one for you, but you might want to also talk about all the new and exciting stuff that we're doing at the museum.
Yeah, that's such a hard one. I have 3 kids, and they're always trying to get me to say which one is my favorite kid. And, they're all my favorite children. I love them all. And I feel the same way about the exhibits at the Air and Space Museum. One of my favorite artifacts is actually Amelia Earhart's airplane. And it's this bright red, cherry red Lockheed Vega aircraft that I absolutely love. It's just kind of, to me, it's got this cheeky red spirit of Amelia, who didn't take no for an answer. She didn't let people's expectations. Women don't do that. You can't do that. It's not done. And she sort of ignored them all. So I really love Amelia Earhart's airplane. But what we're really excited about is right now we're in the process of redoing all the exhibits at our downtown museum on the National Mall in Washington, D.C. We're having to do a lot of repairs of the building. So it's really giving us the opportunity to rethink all the exhibits. So when you come, we're going to reopen the west end of the museum in 2022. So about 2 years from now, and about 5 years from now, we'll reopen the east end of the building. We're going to have a lot more interactives. We're going to have new artifacts that people have not seen before. We're going to tell a lot of stories you don't know, including a lot of stories about people who look like all of us. So no matter what ethnic background you're from, if you're a woman or a man, you're going to see stories about people who look like you, who've done inspiring things. So we're really focusing, as we renovate the museum, on how can we tell these stories of people who didn't take no for an answer and who said, I'm going to keep going either on my team or on my own to change the world. And it shows you anybody can change the world. Any of you on this call today can go invent something, create something, be part of a team that changes the world.
Let's see. Shelby, who's 12, would like to know how to become a pilot.
Shelby, that's a great question. And again, I would start, it depends on how old you are, because there's lots of different organizations that would help out. Again, I would look at EAA, who has the Young Eagles program. There's the AOPA, which is, I'm going to forget what all the initials are, but Google AOPA. They have flight programs for kids in high school. I'd visit your local small airport and ask them if there are local programs you could get involved in. And I would definitely check out Embry-Riddle's online curriculum. It's free for middle school kids on becoming a pilot. The resources are out there, and just Google and you'll find a lot of it.
How are mission names chosen, and who chooses them?
That varies, and I think a lot of people were really excited when they just named NASA's new Mars 2020 rover that's going to launch this summer. It's named Perseverance, and they had a nationwide contest for school kids. And it was a young man in, I think, elementary school or middle school who came up with the name Perseverance, and NASA chose it. So sometimes we have big competitions like they did for Perseverance. Sometimes the team suggests a name and works with NASA to come up with that. So it really varies. A lot of the times, for example, Dragonfly, the mission I'm on, the team actually came up with that name and proposed it to NASA. So it does vary how they pick.
This is a good one. This will crush many children, I believe. Walter is 9 years old and wants to know, do they actually eat astronaut ice cream in space?
Do I have to answer that? Apparently not. And I found this to be crushing myself. I always thought they ate astronaut ice cream in space, but apparently we only eat it at the Air and Space Museum. If you want astronaut ice cream, we do sell it at the Air and Space Museum. It's interesting to taste. Some people absolutely love it. But no, I'm afraid they don't.
It's actually too crumbly from what I understand that it can float off. Okay, hello from Kentucky. I went to fly fighter jets in the military when I'm older, and I was wondering how long will it take from my age, Conley, who is 12, to get to their first flight?
Oh, to actually fly on a fighter jet. I think it depends. If you go to a place like the Air Force Academy, you would probably be able to do it maybe late undergraduate, but usually your early years at even the military academies are spent. A lot of people don't come in with their pilot's license, so you're flying on kind of regular aircraft and then on different trainer aircraft. Okay. And it's usually not until you go into much more specific training. For example, if you're going to be an F-35 pilot, which is a really cool airplane, and I shouldn't put in plugs for movies, but the new Top Gun movie is going to feature the F-35. And I know after I saw the original Top Gun movie, I was like, why didn't I become a fighter pilot? That's the coolest thing ever. So it's usually, you have to be a little bit older, usually post your undergraduate, before you get to actually fly in a really cool fighter jet.
Okay. You said that every profession is used in space. Has there ever been a YouTuber who's become an astronaut, or an astronaut who became a YouTuber?
Oh, wow. Good question. I don't think there have ever been any YouTubers who became astronauts. I'm pretty sure of that. But as far as an astronaut who's become a YouTuber, I don't think so. But you know, at NASA, well, I don't think we've ever had a communications specialist actually become an astronaut. NASA has a huge communications department where there's people who really spend all day thinking about, how do we tell NASA's story? What does the public want to hear? How can we communicate the cool things that we're doing and get people excited about it? So I know NASA's really been trying to figure out, how do we use social media better? For that matter, so do we at the Air and Space Museum. We're really trying to think about how we use things like Facebook Live, how we use Twitter, how we use Instagram to really get people excited. And so we're all really glad you're joining us here today, because we're excited to talk to you about all this stuff that we all love so much.
And we still have a lot of questions coming in. From Chesterfield, Missouri, Max, who's 8, and Elias, who is 5. They were wondering this is a good question. How long does it take to become an astronaut? And also, what kind of rockets are used to take people to the International Space Station?
Right now, the only rocket that's being used to take people to the International Space Station is the Soyuz rocket. So it's a Russian rocket. So the United States buys seats on the Russian rocket to get astronauts up there. We've had to do that ever since the space shuttle was retired. And we had to retire the space shuttle because it was getting very old and people were increasingly worried about its safety. So we've been buying seats on the Soyuz. And right now, NASA is working with 2 different companies, the Boeing Corporation and SpaceX, to start launching astronauts from US soil, which will happen probably, I think, late this year or early next year. I think next year. So stay tuned, because once again, there'll be astronaut launches from Florida. We're really all excited to see that happen again. You know, it really varies how long it takes to become an astronaut. Obviously, once you apply, there's a pretty lengthy application process. Last time, I think, well, it was maybe 2 times ago, they got like 18,000 applicants. Mm-hmm. So the application process is quite long. And then when they get selected, the class are actually called ASCANs, or astronaut candidates. And they go through that, I think, for 2 years. Do you know? I
think that's right. Yeah, because they have to get training. Yeah.
Yeah, and they go through more training. So it's a pretty lengthy process. And as to how old people are, NASA actually does have an age limit. I can't remember what it is for applying to the astronaut corps. But a lot of people, some of them have undergraduate degrees and maybe a career in the military. Some have master's degrees. Some have PhDs. So the amount of time they did sort of life training before they got into the astronaut corps varies all over the place too.
Oh, this is a very important question. And I'm glad this has been asked. Ivan, who's 9, would like to know if you like Star Trek.
Oh, Ivan, I love Star Trek. I'm a huge Star Trek fan. And in fact, right now, you know how we're all supposed to be washing our hands really carefully, and some people are washing them to happy birthday, and I wash mine too. These are the voyages of the Starship Enterprise. That's what a nerd I am. So, you know, I love science fiction. I love Star Wars. I love Star Trek. I love reading science fiction books. And the one thing I really love, one time I was listening to a radio show and they said, no one ever invented something that someone didn't imagine first. So when people think about scientists and engineers, I think they think about, oh, this person has to be good at math and they have to be super logical. I would argue you also need to be creative. You need to think outside the box. You need to think differently. And things like science fiction to me are a huge inspiration for science fact.
Well, one of the things that your employees have enjoyed doing, since we're not supposed to shake hands, has been this.
I'm one of those people that has a really hard time doing it. So I'm genetically flawed.
Have viruses been studied in space?
You know, they have. They've done a lot of work on looking at viruses up on the International Space Station. And one thing we know is viruses actually behave differently in space than they do here on the ground, just like people's bodies do, just like plants do. It's really interesting. Everything here on this planet evolved in 1G of gravity, right? We're all in the same boat here in terms of gravity. It turns out when you take any living system up into space, that 1G of gravity is gone. It actually changes how genes express. It doesn't actually change the genetic code, but genes basically sort of think of them as sort of turning on and off in the absence of gravity or the presence of gravity. There's a lot we don't understand about that. And for example, with some bacteria have been seen to become more virulent or more deadly in space, stronger. Others become more benign, less strong. Why? We don't know, but that's why the research we do up on the International Space Station is so important, and why it has benefits to us potentially here on Earth. Because if we understand more about why those genes are expressing the way they do, we understand more about the virus, more about the bacteria, that might help us develop things like new vaccines.
How does the basic selection process work for experiments and studies looking ahead to space? So how do you decide what you're going to send up to study?
You know, NASA really has thought about that over the years, right? Because when you think about it, there's so many things you could do. Like, look at just my field of planetary science. We have all these planets. We have Pluto too. We have the dwarf planets. We have asteroids. We have comets, you know, and there's so many questions that we have. So NASA actually turns to the National Academy of Sciences here in the United States, and every 10 years, they ask the Academy to do something called a decadal survey. So they look at the next 10 years, what are the science priorities? What are the highest priorities? What are the biggest questions that can be addressed with pretty much current technology that are also affordable within, you know, you can imagine, right, sending humans all over the solar. Okay, that's not affordable. Like, what can be done sort of within NASA's general budget? But above all, what are the top scientific questions that you can get a really good answer to by performing a specific experiment? So NASA turns to the scientific community. So the National Academy of Sciences brings together a big group of scientists. They solicit even more input from the entire science community. And through that, they sort of whittle down to saying to NASA, here's our recommendations for the big science questions that we think you should go over in the coming decade. They update it halfway through the decade because things are always changing. And NASA really pretty much follows those decadal surveys. They're conducted in earth science, planetary science, astrophysics, the study of the sun or heliophysics, and also in microgravity research, so the research that's done on the space station.
Ellen, thank you so much. We have gone way over a lot of time, and we could still keep on going. Is there anything that you would like to say to those students, especially who are watching from home at this time?
You know, I'm so excited that you all tuned in today. So thank you for all your questions. I'm sorry we didn't get to all of them. We can always answer some of them offline. We can all work on getting that done. But please keep tuning in, because every week we're going to be bringing you more really fun people to ask questions of from the National Air and Space Museum. And we hope you come and visit us someday.
And that will be every Thursday at 1 o'clock until the museum opens. Check us out back here. We've got a whole bunch of really great people lined up. Thank you so much for your time today, Ellen, and thanks everybody for watching.
Thank you, everybody.